everybody. Welcome to our session on SQL Server on Linux and containers with Bob Ward. I am your host, Vin Yu, and I am a program manager on the SQL Server engineering team. In this session, we will be covering it in two parts. First, we'll have a presentation followed by Q&A. But throughout the session, we will be taking questions. So do have your answers queued up, or if you want to save it till the end, till after the presentation, as some of your questions may be answered throughout the presentation. You could also save it for then as well. So over to you, Bob.
Hey, Vin, thanks for that introduction, and thanks for everyone joining today. Excited today to talk about SQL Server on Linux and containers. Before I get started, I want to let you know at the end of this presentation, I have a slide that points to the location of this deck of all my demos and other resources. So sit back and kind of relax. If you see some code that you like, don't worry about it. You'll have access to all those resources immediately after the end of this talk. So today, let's do a couple of things. Let's talk some SQL on Linux. Let's talk some SQL on containers. Let's also talk about SQL 19, specifically an area of intelligent performance. Let's first talk about SQL Server on Linux. So if you're a developer and you're thinking about SQL on Linux, consider the fact that SQL Server is an industry-known platform, proven platform. Our TPC benchmarks kind of justify, from a performance perspective, why you as a developer can kind of rely on SQL on Linux. But consider the compatibility story. You build your application one time, and then you deploy your database or your SQL Server in so many different areas and not change your application, whether that be the edge, your data center, or even in the cloud. And if you need certain capabilities for SQL Server as a database developer, consider that things like column store indexes are built into the database engine. And your license includes features integrated with the engine, such as Polybase external tables and SQL Server machine learning services. Now, as a developer, you need the programming language and provider of your choice, and we provide that with SQL Server on Linux. But we also provide a great set of tools for your development experience, including both visual and command line tools that are open source and cross-platform. I've had people ask me since we launched SQL on Linux in 2017, is anybody really using SQL on Linux in production? Consider Team System, an ERP leader that has been able not just to migrate to SQL Server on Linux, and they've been using SQL for years, but they found a way to deploy it in production and use it in an effective way in Azure Virtual Machine. Let's take a look at an example of how SQL on Linux provides some capabilities you may need as a developer. Consider this problem as a developer. You want to use SQL Server machine learning services because you've heard you can deploy Python code with SQL Server in a secure fashion with your machine learning model and just use T-SQL to access the model. But here's your problem. The data for your model is in Oracle. And you're not allowed in this model with SQL machine learning services to connect out of the SQL to the Oracle directly. So how do you get access to that? Well, let's take an example of combining machine learning services with a feature called Polybase. And let's look at some code to see that example. So let me bring up over here this example with a tool called Azure Data Studio. Azure Data Studio being a cross-platform open source tool, and the user interface looks the same whether it's Mac, Windows, or Linux. I'm using something here called a T-SQL notebook. I love these notebooks. It's a combination of markdown text and T-SQL code. And guess what? The results as you run them are saved in the notebook. So I'm showing you an example of saved results to use Polybase to build a concept called an external table to Oracle. Let me show you a couple of key elements here. Number one, you want to define something called a data source, kind of like an ODBC data source. And I'm using, in this particular case, the Oracle data source with drivers built into the SQL installation. Yes, that's true. You don't install Oracle drivers. You just point it to an Oracle instance. So in this case, when I define this data source, I have metadata now in SQL that I can use. My next step is to build something called an external table. External table is going to be just like a SQL table, except when you access this table, the query processor engine knows how to redirect your queries to the remote data source, in this case, Oracle. So I'll map my Oracle columns, my data types. I'll tell SQL Server, this is my Oracle instance and table name. Now, when you query this table, it will be redirected to Oracle. Now, here's what's interesting. Let me skip down here and show you an example of a query. This is a query against this table, and I don't even know now that I'm going against an Oracle data source. And I'm using a where clause. SQL Server Polybase is pretty smart. We're not going to just go get a billion rows from the Oracle table. We're going to push down your predicate, your where clause, to the Oracle system and filter your results in the remote data source and bring back only the results we need. Now in my database, I have this external table. I can use it with my machine learning model. Let's take a look at that example. So first of all, I'm going to build a SQL view on top of that external table. That way, anybody using this view really has no idea I'm even using an external table. But remember, any queries against the view get redirected to Oracle to bring results back. Now, I'm going to do something called train a model. And in this particular case, what I love about using machine learning services is I can take the results of the model and store it in a table. Here's one of the key elements of machine learning services, this system stored procedure. It allows me to run Python code to train my model. And the key elements to this are, number one, a query that's going to be run against that external table through the view. And the output is going to be the result of my trained model, which is kind of like an image file in this case. So I go through that exercise of running the stored procedure and storing the model against old rental data to do predictions for current rental data. So let's go through now and look at how you actually run a model that's been trained. You're going to use the same system procedure. You're going to use, again, Python code running in a secure, isolated way on your SQL server. And you'll notice here, I'm still going to run a query again with current year rental predictions or rental data. And then my parameters are going to be that trained model, and my output are the results of the actual prediction. So if you scroll down, I'm building a table to store those predictions. I'm going to scroll down here now, and I'm going to run that stored procedure, which is going to use the trained model I've already saved, against my current rental data, run predictions, and store them in my local SQL table. And here are the results of those predictions. Consider what we've done. As a developer, you've used the T-SQL interface the entire time to run Python code on a SQL server. That Python code is going to run queries against SQL and access data in Oracle. A really robust new functionality of SQL Server on Linux that can really open up some great development scenarios for you. So let's go back over to our slide deck and let's move on and talk about containers. Why would you consider SQL Server on containers? Well, consider first, unlike other database platforms, we pre-deploy SQL Server in our container image. So once you pull the image, running SQL Server container literally brings up SQL Server in a pre-deployed way in a matter of seconds. And as a developer, you'd like to develop in kind of a free fashion. So the default images for SQL Server come with a free developer edition of SQL and Ubuntu. And then when you're ready to run your container production, a simple command line argument can then now use a licensed SQL Server. SQL Server containers are great for DevOps scenarios, and we're going to show you an example of that in a second. But consider these proof points for containers. Number one, SQL Server big data clusters are powered by containers with SQL Server. Also, Azure SQL Edge, which you've seen an announcement here at Build, uses a SQL Server container in edge scenarios. And then finally, Azure Arc, which we have in current private preview, also uses SQL Server containers in a Kubernetes environment. So there's all sorts of interesting ways that we've proven that SQL containers can be great, not just for development scenarios, but even big, massive production scenarios as well. Let's consider a scenario and a demo for how SQL Server containers can help your DevOps situations. Consider this problem. You're with a group of developers, you're using a shared SQL Server, but you keep colliding with each other. You want to test certain versions of SQL, certain configuration changes to your database, but how do you coordinate that across a team of developers? Azure pipelines with SQL containers can be your answer. Let's go look at some code to see what that looks like. So I've got over here, in this particular example, an Azure Pipelines YAML file. It's how I declare how I want to use an Azure pipeline. And these are a series of tasks using Docker Compose. So my first task is to build my containers. Then I'm going to run a SQL container. Then I'm going to run a container to create my database. And finally, a container to actually test my application. So those are the Docker container tasks. And since I'm using Docker Compose, I have a Docker Compose file defining these containers. Now let me make a small change to this Docker Compose, and I'll show you how pipelines work. I'm going to change my Docker Compose to use the latest cumulative update of SQL Server. So I'm going to save my change, and then I'm going to use GitHub for desktop to push that change up into my GitHub repository. So let's say test with CU4 as my change. I'm going to commit into my branch and push that change up. Now you're wondering, okay, what's happening here? Like, just because you made that change, what happens on the back end of an Azure pipeline? Well, Azure Pipelines can recognize this GitHub repository change and kick off a job with those tasks I defined earlier. Let's see what that looks like. So here's my pipeline I've defined, and I've integrated this with my GitHub repository. So if I click on my pipeline, you will see here that a job has already been kicked off based on the change to my GitHub repo. And this job is going to run those tasks I talked about earlier. So why that job is running, let's go back and look at the Docker code a little bit more. So in my Docker compose file, as I mentioned, I have 3 containers. This is a container to run SQL Server based on our images. This is the name of the SQL that I'm going to connect to in my integrated Docker compose environment. Here's the container to create. Here's the container to run my app test. Well, the create and app test are custom images, and here's what they look like. So the Docker file for the create is going to use our tools image that we've built for SQL Server to run command line tools to run SQL scripts to create your database. And in the end, if you look at this, the script to run the SQL Server database is using the SQL command tool connected to that SQL container in my Docker Compose connected environment. And it's running this SQL script right here. This SQL script looks typical for a create database scenario. I create my database, I create my objects, but here's something interesting to look at, and it's a possibility for you in your scenarios. This part of the script is going to do configuration changes specific to things I need to test with. So now in your environment with Azure Pipelines, you can be testing configuration changes for SQL Server or your database without interrupting that shared dev server scenario I talked about. Let's go back and look at the pipeline and see what's going on in my job. So I'll go back to my pipeline and see what's happened. And you can see now what's going on in my pipeline environment is the SQL Server itself has started up. The create database container has been created, and it's run those SQL scripts. And even my application test is finished as well. Now, in my application test scenario, it's a very simple test of just looking at the version of SQL and number of objects. Right here is where you'd put your application code. It could be your full app. It could be a set of SQL scripts to do sanity checks against the changes you want to do. But notice what I've done. I have run an automated test just by making a declarative change to a new version of SQL Server and testing my app out. Now, what I love about pipelines is the fact that I didn't actually create any infrastructure for this. I didn't create a VM with Ubuntu in it. Azure Pipelines on demand spun up a virtual machine, ran my jobs with all my containers, and spun down the virtual machine when I was finished. This is very perfect environment for your pipelines and DevOps scenarios. And it's an interesting thing for you as a developer to overcome those challenges with shared development SQL servers. Okay, let's go back over to our deck and look at one last scenario. SQL Server 2019, which launched last year, has so many rich features. We've looked at Polybase as one of them in machine learning services. But I want to focus for a second on one interesting developer, and that is called intelligent performance. And very specifically, a scenario I want to talk about is called intelligent query processing. Consider the ability for you to migrate to SQL 19 with Linux, change your database compat level to the latest compat level, not make any changes to your code, and accelerate your performance. That sounds pretty desirable as a developer. Let's look at an example. I'm going to go back to a T-SQL notebook and show you what this looks like. So here's a T-SQL notebook I have, and it's a typical stored procedure that is seen in a lot of environments, a server-side programming model, where I'm going to use something called a table variable. Now, the problem with table variables are we only estimate one row in the query processor, typically up till 19. That can cause problems if there are a lot of rows in that table variable when we generate the query plan. And in fact, when I run this procedure in a loop like 25 times, you're going to notice here that it's going to take some 21 seconds to run that. Now, that doesn't seem like a lot in this little test scenario. What if this was a production system where you needed sub-second response from this stored procedure? This is an issue. Now, consider the fact that I was running the compat level of this database, which was this old compat level from a previous version of SQL. What if I could do this? What if I could run the exact same stored procedure down here, just make a configuration change for the compat level, and accelerate my performance? And you'll see right here, this is now running in 8 seconds. No code changes. Now, let me show you a few query plan details behind the scenes to kind of show you what I'm talking about, what we do to implement this. This is Management Studio, where I'm looking at the query plan for the query that ran slower. If I hover over this, you can see from the query plan details that we only estimate one row. That causes problems for a query plan. In fact, it results in something called a sort spill, which is going to generate suboptimal performance. If I go look at the query plan where I went to the latest compat level, you're going to notice that in the estimations now, we're going to estimate the correct number of rows here, which is going to generate a better query plan for us. In fact, we use a concept called an adaptive join. An adaptive join is something that we're on the fly. We can make join decisions with our query plans based on the amount of data fed into the plan. You didn't make any code changes here. You didn't specify I wanted an adaptive join. It's not a feature of SQL Server. It's built into the query processor. Again, move to the latest compat level, no code changes, accelerate your performance with SQL Server. So as I promised, here are resources for you to get more details. The deck is in the first resource. You can download it right now. All the code I had, I'm an open source presenter. You can just take all this code right now and start running through these demos to see it for yourself. And if you want a lot more information, consider free training from Microsoft Engineering to go even further on what I talked about today on our workshop site. You know, Vin, that was a lot of information, but I think you can see that SQL Server on Linux with features like poly-based machine learning, containers with Azure pipeline scenarios, and SQL 19 intelligent performance kind of together give you kind of compelling story why, as a developer, SQL on Linux and containers might be right for you. Vin, do we have some questions out there? I mean, there's a lot of stuff I covered, right?
Yeah, wow, Bob. I think that was I think that was very amazing. From just when a lot of folks think about databases, they think about getting the data and storing the data. But from doing things like poly-based machine learning, working in containers, and then just knowing the fact that it's all tied together with just better performance, just knowing it runs faster just by using the latest version. I think.
And Vin, these aren't add-ons.
amazing.
This is all part of the product. When you
Wow,
get
yeah,
some
yeah.
extra containers, you get all of that. It's not like an add-on or something like that. Yeah.
Yeah, that's great. Yeah, so folks, just as a quick reminder, we will be taking questions Q&A live now. If you had a question queued up, so do ask away. Meanwhile, if you don't have a question yet, do check out these resources. I can't emphasize enough that there's so much more that we couldn't even fit into today's sessions that's behind the scenes in these links.
Absolutely.
Yep. All right. So let's just go ahead and I'll get this started. So we have one question from a user.
Okay.
Given that they are a long-time Windows user, they asked, if I have a choice of platform to make, should I choose SQL Server on Windows, and when should I choose SQL on Linux?
Vin, I get that question a lot. When we launched SQL 17 on Linux, a lot of our SQL community on Windows was asking, like, why did you do this? It's all about platform of choice. I know that sounds kind of trite, but it's really true. As a SQL Server user, SQL Server on Windows and Linux use the same code base. It's the same engine bits. So your choice should be more about your operating system platform, not SQL Server. SQL Server is going to compatible and run the same. You can take a database backup on SQL on Windows, restore it on Linux, and your app just works the same, or vice versa. So that choice should be in your company or as a developer, where do you want to host a SQL Server? Is Linux best for you or is Windows best for you? So it's not a SQL Server choice necessarily, but more of the platform choice. And then I've seen customers use a hybrid model. In some cases in their company, they may have acquired a new company that prefers Linux. Now that opens them up to run SQL Server across their entire enterprise, both with some Windows installations and some Linux installations.
Cool. Yeah, so we have another question. Chad asked, I'd love to know if there are any plans for creating a Kubernetes operator to handle replicated pods in a Kubernetes cluster.
It's a great question, Ben. In SQL 19 in preview, we did kind of experiment with the idea of using operators for availability groups and other coordinations. And Ben, I know you've actually spent some time in this space, kind of even deeper than I have. So why don't you share a little bit your thoughts there?
Yeah, everybody, I'm working actually in the container space, some of the stuff that Bob presented today. And yeah, this is actually something we're taking feedback for right now. But if you are looking for a product or something that that could deploy SQL and manage the deployment and lifecycle of it, do take a look at Azure Data Services, Azure Arc. What this product's gonna be able to do is offer a SQL engine deployed through containers on any Kubernetes infrastructure and managed lifecycle. But we are still taking feedback and looking at some of the scenarios and use cases for an operator as well. All right, so we have another question from Zahir about, does external data source replace link servers?
I've had that question from many SQL users because it kind of feels like a link server. One big key difference is that external data sources and external tables are database objects. Link servers, of course, are instance level objects. So you define things at a database level with polybase, which means, is really important, it is contained in your database so it survives a backup restore. You don't have to coordinate link server instance configurations with your database, and really great for availability group scenarios because if you fail over, your Polybase data sources are all just living there because, again, they're part of the database. The other thing is I would say is that we probably have a better integrated story with our query processor engine. We're using Polybase technology from the Azure DW team to make this a very scalable operation. So for example, Polybase scale-out groups allow us to partition out workloads across SQL instances or even containers in the case of big data clusters, and get a more scalable, performant scenarios with Polybase. So there's several differences, the biggest one being database contained objects, but I would say we've got a more integrated performant experience with Polybase queries, Polybase external tables. But one other key point, SQL Server, Oracle, Teradata, MongoDB, those are built-in drivers into SQL Server when you install Polybase. For Link servers, you're responsible for external data source drivers being installed on the SQL Server itself. For those data sources, we install those by default, and we support those as well.
Yep. Duncan had a question about, how are there any examples or best practice recommendations about, achieving minimum downtime schema updates or upgrades with containers?
That's a great question. One of the things I love about container technology is the ability to start up a container, point it to shared volume storage where you may have your databases and so forth, and then being able to stop and start up a new container, because remember, these are pre-deployed SQL instances that start up in seconds. And things like cumulative updates are even compatible between each other. So the ability to start and stop containers pointing to the same set of SQL databases is a very powerful way to get up and down very, very quickly. Plus these pipeline scenarios we talked about, right? The ability to customize your images with all the schema changes you need, and then again, point them to another customized container and get up to speed in seconds. I would say, Vin, you've spent some time here, but that's some of the scenarios I've seen in this space.
Yeah, I totally agree with that. Exactly what you said. I'm not going to repeat that as well.
Yeah.
Is Windows authentication, Volker asked, is Windows authentication available inside containers?
Today for SQL Server on Linux, we have Active Directory authentication built in today where you can configure it. So it's going to be a slightly different configuration experience than Windows, but you still have the idea of integrated security. For containers, we are almost ready to deliver that type of functionality. We're very close to that, so be looking out for soon from us information about how to do that in a containerized way.
Yeah, I just love to add to that. So Volker, we do have plans, and this is coming to preview very, very soon.
Yeah, I think you'll like the experience too, Vin. I think I remember, if I think correctly here, we're even just improving the overall Active Directory configuration experience on Linux in general, correct?
Oh, totally. Yes.
Yeah.
I think that one thing that we realize, the Linux community has done some really good work on how to enable things like Kerberos authentication with, that works well with the Windows ecosystem. But one thing that we thought when we came here to work to start adopting Linux was, how do we further advance and stand on the shoulder of giants, if you may,
Right.
continue to build off of this and just improve the experience for everybody. So,
Yeah.
So we have a question about licensing. How, what is the licensing? Pablo asked, what is the licensing for SQL Server on containers?
That's a great question, and I don't have any diagrams for licensing. Sometimes it gets a little complex, to talk about how we do licensing. But we have a complete licensing guide for SQL Server that's got a dedicated section for containerization. I think you'll find the software assurance licensing model will really help you for taking a look at that. Remember, though, that the developer edition for SQL Server, which is the default container, is free for development scenarios. But to actually license SQL in a production environment, per se, Enterprise Edition or Standard Edition, our licensing guide gives you all the details. It's similar to how virtual machines are licensed. But again, for software assurance, you're going to find a lot more flexibility in how you license containers.
Cool. Yeah. Alex asked, how difficult is the upgrade process or rollback process? I'm assuming Alex is meaning containers.
Yeah, probably so. And let's be clear about a couple of terms. So upgrade, I consider like a major release change between SQL Server, SQL 17 to SQL 19. And in a containerized environment, you'd be surprised. You can actually do that. You can actually take a SQL 17 container, stop it, take the SQL 19 container, point it to your set of system databases and user databases, and we will indeed upgrade on the fly that scenario. Now, you can't roll back in that situation because we don't allow that between major versions of SQL. But consider the cumulative update scenario. You have a situation where, in the example I just showed you, I was running SQL 19 cumulative update 3. And if I want to move to CU4, I can simply stop one container, start another one, point it to my same set of databases, and we will be up and running in less than a minute. And then if you have an issue there, you can completely roll back to that previous CU. This is because CU cumulative updates are compatible between each other. So I call that like the switch method, not necessarily even the update rollback method.
Yep, totally agree how it is. I mean, if we had the opportunity to show you in a demo today, I think, many folks would be fairly surprised how easy it was. Yeah.
Hey, Vin, by the way, in that SQL workshops resource that we have up in front of you, if you'll go look at the SQL 19 workshop, there's a complete lab on how to see that experience between switching between containers. You can try it out for yourself.
Oh, great. Yeah. So folks, again, do check out the resources here. I think some of the questions that you have here that folks you've been asking, we even have labs for those. So if you want to try it out,
exactly.
check out the links. Yep. We have a question from Frank now on, how can we run Python in Azure SQL or in containers?
Right, that's a great question. So first of all, running Python machine learning services completely supported with containerization or SQL Server on Linux, that's all there today. And we are currently evaluating how do we bring the machine learning services environment to Azure SQL, like for example, like a managed instance. You can do it with a virtual machine today, but today in our PaaS environments, that's not supported, but certainly something the team is taking a very hard look at. How would we light up, for example, a machine learning services model with, say, Azure Managed Instance?
Yep. We have a question from Brent. Are there any performance metric comparisons between Polybase connecting to Oracle or a remote data source versus ETL approach of moving data to a staging area?
We haven't done any performance tests necessarily, and you may be able to create an ETL model that can give you overall better performance because you might find that you don't need to have access to your data in Oracle on an ad hoc basis every minute. So it might be more efficient for you to do an ETL job and stage it in SQL than access it there. In fact, in a big data cluster, we have something called a data pool, where often what you might do is run queries against Polybase sources, take the results of those queries and store it in our data pool, which is an automated set of SQL instances for you using column store, and kind of use that as your caching system of your offline result system. So it depends on your needs. I've even seen some customers are using a combination of these things, or even for incremental migration scenarios. So you might build a SQL view like I did on top of an Oracle external table. And then you slowly but surely migrate your Oracle data into SQL Server, and the view just stays the same. And you never knew the whole time you were using Oracle or local SQL data.
Yeah, I just love to add to that is, often, when folks are asking this question, I think the answer is it's not or versus, but it's and. A lot of times it really depends on the scenario, and if you're using this, if you're querying it very frequently and long-term wise, ETL could be a complementary approach. If you're doing this maybe once or twice a month approach, ETL job could be costly in some cases, and this is where Polybase comes in, and that was one primary reason why we introduced the improvements that we did there.
But keep in mind this, we integrate in the query processor our access to these data sources. In fact, you're able to actually store local statistics based on like an Oracle data source, your tables, into the SQL Server local database. So then the query processor can look at stats to make smart decisions on these queries. So it's not just blindly throwing queries at Oracle. Now, the performance of your Polybase queries against, say, an Oracle system are only as good as Oracle. So if you don't have any indexes over there, right, we can't run all that fast. So you need to make sure you can run as fast as a native Oracle client on, say, the SQL Server system.
Yep. Hey, folks, I'm sorry that there's so many questions here. It's really good, but we only have time for one more question. I know, we got to step out so that we can so that everybody here can get to the next session. So the last question that we have here is SQL Server database files interchangeable from Linux and Windows version?
But I'm so glad you asked that, Vin. I get that compatibility type question all the time, and the answer is 100% yes. Here's why. We use the same SQL engine code bits between Windows and Linux. We use a concept called the SQL PAL that allows us to do this. You just go do a search. You'll find some really cool information we posted out there called SQL PAL, SQL Server. We talk about the details of that. But database files, database backups and restores, all compatible to be switched back and forth in these systems. No need for you to convert anything because, again, the engine code bits are the same between the two systems.
Cool. All right, folks, that's all the time we have for questions. Really thank you for joining us. Bob, any last words?
No, I want to just thank everybody for joining us. Just consider everything we talked about today and more out there. SQL Linux compatibility has features that built into the product itself that you need, not add-ons, Containers, so many different options for you containers, but consider those pipelines scenario I just talked about. That's really powerful. And then SQL 19, there's just so many great features built into that, all built into Linux as well. Intelligent query processing, don't change your code, just get faster. Those are pretty compelling reasons to consider Linux containers and SQL 19. So Ben, thanks for having me today.
Yep. Thank you, everybody.